you for attending my talk. I'm going to be talking about strategies for teaching methods for analyzing data and the necessary computer-based programming to MPH students. So just a little bit about the motivation for my talk. Mastering data analysis concepts and programming simultaneously in a course can be an overwhelming challenge for students. And part of the reason for this is if we think in practice the skills that we need to be able to analyze data, we really first need to identify what the appropriate analysis is. We then need to have the confidence to go to our software of choice and actually run that analysis, and then we have to interpret those results. And so for students, this can be really challenging because there are really these different pieces these different things that they have to do, but they lack the confidence in any of these one individual pieces. So they lack the confidence when they first go to identify, and then the program or what they run depends on the identification that they made, and then the interpretation depends on the output from the software. So the methods that I'm going to be presenting here are really designed to help students build some of that confidence as well as some intuition, and it breaks these down into different steps that allow the students to do that. The methods that I'm going to present, I've used them in Introduction to Biostatistics, Linear Regression, as well as a Generalized Linear Models course. Now, the Introduction to Biostatistics course and the Linear Regression, these were primarily MPH students. Generalized Linear Models, that course was primarily PhD students. And so the bulk of what I want to present here is really an augmented version of the spiral approach to teaching that I've tailored for data analysis. And so to explain what I mean by this, I want to first kind of broadly talk about what the structure of the course looks like. So the course was really broken down into three components, or three major components. There were labs, lectures, and homeworks. And students also completed projects, but I'm not going to talk about that here in this talk. I really want to focus on the lab, lecture, homework structure. So typically what would happen in any given week is that students would first start with a lab assignment. So the very first lab assignment in the course introduced the students to the software. And in most of my courses, I'll use either SAS, R, or both, and I'll talk more about that here in a moment. After the lab, the next class period would be a lecture. And the important part about the lectures is the lectures include no code. They only include output. So during the lectures, that's where students would learn about new concepts. They would be given the output that was necessary from the software, and then we would focus on the interpretation. Homework that week would focus on the material from the lecture. And any output that the students would need, all the necessary output would be provided. So lectures and homeworks were really focused on allowing students to learn about the concepts, learn about the different analyses, and practice the interpretation of those analyses. The output, or the necessary pieces from the software, was always provided. That homework would be due before the next week's lab. So in the following week's lab, what the students would learn in the software is how to produce the output used from week one. And so they would produce the output not only found in the lecture, but also that output from the homework. And this is where the spiral piece comes in. So again, prior to lab 2, the students will have already turned in the homework, so they've learned about the concepts, they've learned how to properly interpret things, and so now they can really just focus on that coding aspect and practice that skill. And what's nice about this is, since this occurs at the beginning of the week, students are really forced to review the previous week's material because that's embedded here in this lab. And what's nice about this, as they learn to code and that code produces output, they can actually compare the output that they get to the output from the previous week, and this helps them build that confidence. Because if they don't get the output that they're expecting, then they can really focus on the code and correct what they need to correct there. And then this cycles for each of the weeks in the course. And so you'll notice what naturally happens is each week after week 1 starts with the review of the previous week. Students are able to focus on the code, and they're able to build that confidence with coding. And then in the lecture and the homework, again, they're really able to focus on things like, what is the motivation for this analysis? Why do we choose this one? And how do we interpret it? And so I want to show some examples of what this looks like in the classroom. These particular examples come from the linear regression course, and again, I taught this for MPH students. So usually when I like to use lots of examples, so I would start out with an example. This would provide the motivation for the particular analysis or what the students would be doing. That motivation would be followed by the output. Now in this particular course, I used both SAS and R, so a lot of times for the examples, I would have the SAS output and I would have the R output, so they would get used to reading the output. And again, no code in the lectures, so I wouldn't say, hey, this is what you do in SAS to get this is what you do in R. I don't want the students to focus on that at all. It really would just be, okay, here's the output. How can we read that output? And then, of course, these would be followed with examples of the interpretations and how to interpret that particular output. The homework would follow this exact same pattern. They would have a motivating problem. I would give them the output, and then they would work on the interpretations. So the homework really was made to mimic the skills that they learned in the lecture. And so again, the idea here is to help them build that confidence and also help them build that intuition, because they're mimicking in the homework exactly what they did in the lecture. The format of what they're seeing is not surprising. They really can focus on the content as well as the interpretation. And so this would happen in a single week. I think these came from week 5 or week 6 in the course. And then beginning the very next week, what they would do is they would work on a lab where they recreate the output from lecture. And how the labs were set up is I would walk the students step by step, first in R and then in SAS, so it would be split into 2 different sections. And the first thing I would do is I would walk through it with them step by step, how to create the output that they saw in the lecture. So again, whenever we would get output in SAS or R, we could go and we could compare that to the lecture. They would see, okay, this was the output that I was expecting, again, helping them build that intuition. And then in the lab, I would have practice problems set up, and each of the practice problems in lab mimicked the homework problems from the previous week. So now as students wrote the code for these, what they would do is once they got their output, they could then go and compare that output to the homework. And so again, we're helping them build that intuition, helping them build that confidence. And if they don't get the output that they were expecting, then they know the issue was with the code. So this eliminates this problem that students often have, which was, hey, I wrote some code, I got it to run, but did I get the right thing? And so it's helping them build that intuition, build that confidence. And again, since lab occurs at the very beginning of the week, this also helps review some of those concepts from the previous week so that we can start the following lecture and they've already reviewed that material. And again, key to this is that the homework from the previous week is due before the students actually work on the lab, so that way we can ensure that they've already worked through some of this material on their own. So in addition to this augmented spiral approach, there are other things that I've included in my courses to help with this. And one of them is the inclusion of multiple software programs in a single course. So a lot of times, we question, should we use R, should we use SAS, should we use some other software? I've started including multiple softwares. And again, part of the reason for this is to help students build that confidence and that intuition. In the linear regression course, I included both SAS and R. And so what would happen is after the student completed a portion of the lab with R, they again, they have looked at the output, they know what numbers to expect. So then when they move on to SAS, they already have this intuition about what numbers they should be seeing in the output. And so they can really focus on the coding aspect and how they're writing the code to get the output that they're expecting. So it's all about building that intuition. And this also, I think, helps prepare them better for when they go to enter the workforce. Before actually getting a job, a student isn't going to know what software they're going to be working with. So the more flexible a student is in terms of working with software, the better it's going to be for them once they enter the workforce. So by looking or using 2 programs in a single course, it helps the students not get used to only one type of software. It makes them more flexible in terms of what they're able to do. The other piece that's important is the idea of real-time evaluation of student learning and teaching effectiveness. Students often struggle with the code and how to actually code, and when they're doing this by themselves at home, this is a real challenge because they struggle with troubleshooting. So by having the lab take place during class time, I'm there to help the students with their coding and to help them with the troubleshooting. By being there with them while they're working on this, I get real-time evaluation of how they're doing. Do they understand why they're coding what it is that they're coding? Do they understand how to interpret that code once they actually, or interpret the output once the code runs? Being there live with the students while they're working on this really gives me an understanding of if the students are understanding what is happening or if there are certain concepts that I need to review. And again, it also helps with that evaluation of teaching effectiveness. Is the way that I'm presenting the material, are the students understanding it, or could I do a better job? Maybe if I, rework the material a certain way or present it a different way, are the students going to understand better? And I can try these things in real time because I'm having the students work on problems in the classroom. So I really get a good feel of, are they understanding? Is this working well for them? So just to kind of summarize, some of the things that I've talked about, the main thing is this spiralized approach to, teaching both concepts and coding. One thing that we can do for students is to split this in two pieces. Use parts of the class to really focus on the content and the interpretation, and use a separate part of the class to focus on the coding. And if these are done in sequence, really what this does is it creates a spiralized approach for the students that helps them build intuition, but it also helps review the concepts as you go along, and this will hopefully help the students build confidence in both the content as well as the coding aspect of the course. I recommend using more than one software. Again, this is meant to help students build that confidence when they work with different types of software, and it also makes them more flexible so that when they enter the workforce, they'll be able to adapt to whatever type of software their job is using. And then finally, the last piece is this real-time evaluation. I find that having students work problems or work exercises in the classroom allows me that real-time ability to determine, are the students understanding, and is the way that I'm teaching the students, is it effective? So again, I'd like to say thank you for visiting my talk. If you have any questions or you'd like to talk about this topic, please feel free to email me.